All right, recapping from yesterday, the parabola. If a parabola opens upward, does it have a minimum or a maximum? But if it opens upward, a minimum. All right, so at the that would be our point right there. So that would be a minimum point. So minimum. All right, what if it opens downward? What do you think it's going to have then? A maximum. So that would be a maximum. What is that point called? The one that's the minimum or the maximum? A vertex. Another word for x-intercept. Do you remember any of those words? Zeros is one. Solutions and roots. All right, so all of those, you'll see different ones. I'm going to ask you different ones on the problems on the assignment, but I'm asking for the same thing. They're all x-intercepts. All right, what about solutions? How many solutions could it possibly have? It could have 2, it could have 1, or it could have 0, right? It just depends on how the graph is hitting that x-axis. All right, the axis of symmetry, the AOS. This is a line that's vertical or horizontal. What do y'all think? It's your vertical line. It's the line that splits your graph directly in half. All right, in this equation, is it always x equals or y equals? Do you remember? It's always x equals. X equals in whatever number that may be. All right, 3 new words. In regards to this graph, we are looking at domain today. We are looking at range. Your domain is going to look at how wide the graph is. Range is going to look at how tall it is. And then the last thing is the y-intercept. This is going to be where it crosses the y-axis. So yes, we have an x-intercept. We also have a y-intercept. We ready? All right. So all these equations we see actually come from one equation, and that is your parent function, and that's going to be y equals x squared. Now the y equals x squared, it hits 0, 0, it hits 1, 1, 2, 2, 3, 3, 4, 4, and so forth. So if you notice this point here is at 2, 4, so negative 2, positive 4. This point here is at negative 1, positive 1. The vertex is at 0, 0. Your next point up here is at 1, 1. And your second point here is at 2, 4. All right, so all of those points we just got from the graph. Now we can go ahead and connect them. Remember, when you connect them, you want to make a U. What direction is this opening? Is it opening up or down? Up. So the parent function always opens upward. Does it have a minimum or a maximum? A minimum, good. What are the coordinates of that vertex? Where is that vertex located at? 0, 0. All right, just a reminder, that is your vertex. All right, how many solutions does this one have? How many times is this graph touching the x-axis? Only once. And where is that point at? 0, 0. All right, what if our axis of symmetry? 0. All right, so this is going to be x equals 0. And just a reminder that your axis of symmetry should always match that x value from your vertex. So these two should always be the same. You can highlight them if you want. You can box them in, but those two should always be the same. All right, where is it crossing the y-axis? So the y-axis is that happens to be the axis of symmetry here. Where is it crossing the y-axis at?
0.
At 0. Now, again, this is only the parent function. The parent function is the one that has all this. So your y-intercept is 0. Now, I want y'all to know the difference. Your solutions or your x-intercepts should always be an x value and 0. Your y-intercept should always be 0 and then a y value. They're opposites, okay? So those are going to be the ones we're looking for because you can always find those on a table because that's what we're going to do. All right, the domain. The domain is how wide the graph is. The graph comes up to this side, to the left, and it goes up to the right. Now, if you notice, there's arrows at the end, and what do the arrows indicate? That they continue. Now, what that means is that we have a point here. If I take this point here and I pull it up, there should be a point here that will eventually cross it, right? Because that arrow is going to continue. Even if I came to this one, to that -5, and I went all the way up, there should be a point right there at that -5. So your domain for your parabola or for the quadratic is going to be all real numbers. All real numbers. Always. Your range, you will have a range. Your range is how tall it is. So in this case, you have a low point. Your low point is here. And that's hitting what number on the y-axis? What number on this axis is that line hitting? 0. Now, if you follow your graph, are the y values going to get bigger? Or are your y values going to get smaller? Bigger. So your y's, whatever your y's may be, are going to either be greater or equal to 0. So your range, you will have a number. It should always be y. All right, and it's either going to be greater than or less than a specific number. All right, let's go over to the back side. All right, on the back side, let's go ahead and graph these points. Let's graph -2, 0. Let's graph -1, -3. Let's graph 0, -4. 1, -3. And 2, 0. All right, and then you'll just go ahead and connect them to make your U. All right, so what direction is this one opening up? What direction is this graph opening up? Upward. Is this a minimum or a maximum point? A minimum? All right, what's the value of the vertex? Where's the lowest point at? 0, -4? All right, I want you to look at something right here. If you look at that point where the vertex is at, I want you to look at the x values because you're not going to always have a graph. So when you don't have a graph, I need you to look at the table. There is a -3, -3. There is a 0 and a 0. Do you see how they're repeating? That one that's in the middle before the repeating continues or begins, that is always your vertex. Because we're going to look at a table here in a minute. So your vertex here is at 0, -4. All right, you're going to always be looking at that part where that break happens. All right, looking at solutions. Remember, your solutions are always x's with the 0. That means you have a number with the 0. Do you see that anywhere on your table? -2 and +2. These two are your solutions. It's -2, 0 and 2, 0. If you look at your graph, that's exactly where it's hitting the x-axis. Again, if it's a graph, it's a little easier. But if we don't have a graph, we should be able to pull it from the table. All right, what did we say yesterday? The axis of symmetry is always in x equals form, but it should always be which value? The one from your? What? What should match here? The vertex. This value here, so this is where you want to use your highlighter. Highlight that number and highlight this number. Those two should always be the same. All right, because we're going to use it here in a minute to figure out our pieces. All right, reminder, your y-intercept is always 0 and then a y number. Do we see that anywhere on our table? 0, -4. And if you look at your graph, that's where your graph is crossing the y-axis. This is your y-axis. This is where your graph is crossing it. So it's crossing at 0, -4. All right, and let's see if we remembered. I said domain. Domain is going to always be all real numbers, always. Your range, you should have a y. You should have a less than or greater than symbol depending on what we have. So you always go to the y-axis. In this case, you have a low point. It happens to be here at -4. So are my values, are they increasing or are they decreasing? Increasing. So if they're increasing, y is going to be greater than or equal to -4, which is the number where it's crossing the y-axis at. All right, do that one more time. This time we're going to pull out the table, okay? So on your calculator, we're going to graph this equation. All right, so open up your calculator. You're going to go to home. We're going to go to new. You want to go to add graphs. All right, we're going to enter x squared minus 4x plus 4. All right, that's our graph. That's what we should have after we graph it. All right, how do we look at our table? What do we go to? We go to Control T. All right, let's go to Control T. I want y'all to start copying here at 0. I want y'all to copy 0, 4, 1, 1, 2, 0, and so forth. And then I want you to graph it on your paper. You're going to fill out your table, and then you're going to graph it on your paper. All right, so what direction does this one open up? Does it open up or does it open down? Up. So it opens up upward. Does it have a minimum or a maximum? Does it have a minimum or a maximum? A minimum. Where is that vertex located at? And if you forget, look for your pattern, right? 1, 1, 4, 4. It's that break. So our vertex here is at 2, 0. All right, mind your solutions. Again, solutions are x, 0. And there's only one on this graph. What is the solution on this one? What point is hitting the x-axis? 2, 0. It happens to be the same number. Doesn't always happen, but it could. All right, what's our axis of symmetry then? What point does this line go through? 2, 0, but how do we write it for the equation of axis of symmetry? X equals 2. All right, our y-intercept, where is this graph touching the y-axis? It's touching it at 4. And again, your y-intercepts, your point should be in the form of 0 and then a number for y, which happens to be here. This is your y-intercept. So 0, 4. All right, what did I say the domain was going to be? All real numbers. And then our range. What you're going to do here, because this one's not touching the y-axis, you're going to take the lowest or the highest point, and you're going to drag it over here where it touches the y-axis. So you're going to make a little line here. And then from here, you're going to decide, is my graph, or my y values on the graph, are they getting bigger or are they getting smaller? Bigger. And just follow your graph. Just follow the direction it's going. It's going up. So you're going to say your y's are getting bigger or equal to 0. All right. Now to pull everything from the table. All right. I want you to find the break. Where does that pattern happen? Find me the pattern. Where does that pattern continue? Where's the break at? All right, where's the break at? 2, 6. All right, let's just check that. We say it's 2, 6. Make sure it repeats. We have 5 and 5, 2 and 2, -3, -3, and 9 and 9. So yes, that is your vertex. It's at 2, 6. Now that you have your vertex, we should know the axis of symmetry. What's the axis of symmetry? 2. Because these two always match. All right, y-intercept. Remember, your y-intercept is in the form of 0 and then a y value. What is your y-intercept from the table? 0, 2. This is your y-intercept. All right. Let's go over to the right side. We're going to look at the exact same things. On the right side, though, you're going to have to figure out your own solution. All right. So I want you to find me the vertex. Where's the vertex at? Look for the break again. 0.15. So if we want to think 0.15, make sure the pattern's happening around it. So do these two match? No. All right. But that's a good try, right? Because a lot of us will think it's a 0. What other one? -1, -16. Do the ones around it match? Yes. Now, we don't have anything above it, so more than likely those should all be repeating. So this is your vertex. I want you to go ahead and label that as your vertex. They want to find the other solution. So the problem says, a table of values for the quadratic function f is shown below. If 3 is a solution, what is the solution of the other? So this is one solution. This is a solution. What is the other solution? So what we want is we want the other 0 up here. So what you're going to do is you're going to keep repeating it, just like we saw the pattern. So if this is -12, this one here is going to be what? -12. And you're going to write over this. You're also going to be writing in the paragraph. That's fine. If this is -7, the one up here should be -7. And this is the one we want. We want to know what's paired up with the 0. So 0's here. Now, the left side's even easier because it goes in order. 0, 1, 2, 3, 4. So -1, -2, -3, -4, -5. This is your other solution. So our answer is, our other solution is -5, 0. This is our other solution. Now, I know it didn't ask for it, but we did identify the vertex. So if you know your vertex, what is your axis of symmetry? X equals -1. It's always the value of the vertex, the x value of the vertex. All right, and since you're here, let's go ahead and find the y-intercept. Remember, y-intercept is 0, y. Do you see any point that has that format? 0 and -15. That is your y-intercept.